Thanks for coming to Lunch with Larry again. Today's topic is, of course, design control. We're on our fourth of the series. Today, we're going to talk specifically about risk management and the integration of risk management with our requirement set. My contact information is here. Got a registration link for this webinar series. If you want to give it to one of your friends, we'll repeat this series later, and hopefully that provides you with an opportunity to engage with this topic again. Also have my Lunch with Larry YouTube channel. Please subscribe, and I've got all my other contact information here if you want to get a hold of me to talk about whatever it is that you're concerned about. So happy to spend an hour and get to know you a little better. So feel free to call. Okay, so when we talk about design control, of course, we have this core set of data element requirements management. The requirements are informed by a variety of different topics, but we have this first iteration, or first perspective, which is systems modeling, followed by external standards management. How do we map in an industry understanding of how some scope of work should be done? Our verification and validation testing, which is our evidence that the device complies with our definition of good as defined by the requirements. And now finally, we're going to talk about risk management. And what we're going to do in risk management is take a negative view of the design. What do we need the device not to do? How do we assure that it doesn't do something? That's really what risk management is all about. How do we analyze the data to be sure that we have an appropriate mitigation to every problem that we've identified? So that's really what today's topic is and how it fits into the rest of the design control discussion. We have medical device templates. I just wanted to outline that. So if you have any kind of problem with this, data management, how do these things integrate together? We have a pretty rapid way for us to discuss and implement this in Polarian if you'd like to have a template and make this whole process easier. Okay, so now in the past, we were talking about requirements management, and we have this decomposition from user needs down to process controls. And the format is sort of loosely described in the 1997, I believe it is, design control guidance that the FDA put out. And in addition to this sort of linear breakdown, we also have these refinement relationships to provide us with enough granularity and the ability to manage a certain amount of complexity in our designs. So if we start with this as our core and we've already deployed the requirements management, the next step is going to be for us to integrate into this both of our systems modeling and our risk management. So in one of the previous sessions, we then spoke about systems modeling, the decomposition of capabilities into their commensurate functional chains and the functional chains into their functions and the functions as they're deployed in a component of the system. Functional chains are deployed across multiple components of the system. So once we understand functionally, we have this formal understanding of how the device functions, we can then map that into the requirements as a characterization of the outflows of those functions. So that's really the systems modeling aspect of the traceability into these requirements. So the question then is, how do we define good product? Well, the way we do that in part is with risk management. And so we're going to start at the top end here where we have a harm and a hazardous situation. And the harm and the hazardous situation need to be paired. So we have one harm and one hazardous situation. I'll give you an example. We have a wire, the conductor has been exposed, we touch it. And when that happens, when that hazardous situation occurs, when we have this mechanism by which a user is exposed to electromagnetic energy, we can have a variety of harms come out of that. One might be electrocution, where we fall over dead because our heart stops and it's death. We might also have just electrical shock. And so one of the problems that you have when you're making these definitions is dependent upon what the harm outcome of that hazardous situation is, we might have a different occurrence rate that's associated with it. So now each one of the hazardous situations has what's called a P1 factor. This is based on the 14971 risk management protocol, the appendix in that document. The P1 factor is how often that hazardous situation occurs. And that's carried inside the hazardous situation. This is the only thing really that we can adjust to mitigate the risk in our system. So we have a pre-mitigation P1 and a post-mitigation P1. Then when we pair the hazardous situation to harm, what we're going to get is what's called a P2 factor. And that P2 factor is how often the hazardous situation converts to the harm. So when I touch that wire, maybe 0.01% of the time I fall over dead, but maybe 100% of the time, it shocks me. So that P2 factor might be 100% in the case where we've paired it with shock, but maybe much lower percentage when we pair it with something that leads to death. And so that P2 factor depends on the pairing, which harm and which hazardous situation we're talking about. So because of that, the risk record then carries the P2 factor. How often does it convert? And that is something that typically doesn't change regardless of what you're doing from a mitigation strategy. If I touch the wire and I expose myself to that electromagnetic energy, how often I get shocked or how often I fall over dead is not going to be different really based on my mitigation strategy. What I can do is I can reduce the P1 factor. So the mechanism by which that conductor becomes exposed, does it become exposed? What's the mechanism by which it does that? Those are the kind of things that I can mitigate, but not so much the conversion factor. So then in the risk record, we're going to pair the P1 and the P2 to get P. And what P is how often does the harm occur? Now, in many companies I've been involved in, and I would say maybe even more often than not, people don't look at the P1 and the P2 factor. They only look at P. And that's because they can see in the field how many occurrences of the harms have happened. But this mechanism, how does the hazardous situation play into it? And what is that occurrence rate of the hazardous situation? They don't understand that very well, so they just don't track it. Now, the problem with that is what the theory would tell you is you can't control the occurrence of the harm unless you control the P1 factor, which is the hazardous situation. So the first thing we want to do is assure that we have control over that hazardous situation occurrence, so we need to track it. Okay, so that's sort of this hazardous situation harm risk record group. So now what we want to do as a mitigation is we want to attach it to the hierarchical breakdown of the requirements. So not only do we want to attach that hazardous situation to design requirements and physical requirements or whatever in the progression, but we want to think about it systematically. What are we going to do to assure that we have a validation and all of the requirement verifications that are necessary to control that user need? So I'm going to give you an example from a sterilization standpoint. We have a harm that is patient infection, and we have a hazardous situation that a non-sterile device introduces bacteria to the patient. We need that hazardous situation to be at a high level because the definition of a hazardous situation is the mechanism by which a hazard is exposed to a user. So we need to understand what's happening at the user level for us to understand what the hazardous situation is. Now, what a lot of people will do is they'll have a discussion about errors, and errors happen in the design. And then what they do is they attach it directly to the harm so that they understand what the severity is. What we want to do is have a systematic approach. So in this case, we have a harm that's infection. I told you what the hazardous situation is. The user need would be that the device be delivered to the patient sterile. So you can imagine that if you break it down like that, what you're going to have then is many different system requirements. You're going to have system requirements around packaging. You're going to have system requirements around how the device is sterilized. You're going to have requirements around aseptic transfer techniques from the non-sterile nurse to the sterile nurse. So there's a whole bunch of things that need to happen in the system to assure that when we deliver that device to the patient, that it's sterile upon use. So we need to have a systematic view. And the user needs are the head of that, but the system requirements really define all of the mechanisms and what the design needs to do to put us in a position where when it ends up at the user, that it's in that sterile state. So these requirements, the user needs, system requirements, design, physical, and then process controls represent the entire mitigation strategy. And in the regulation, it talks about these levels of mitigation in order of preference. So the most preferable one is inherently safe by design. Well, where do we define what is the design? It's really the requirements. So we need all those design requirements to end up being mitigations to our problems that we discover, the errors that we discover as we do the risk management going forward. So inherently safe design is captured in the requirements. And then there's protective measures, either in the design or in the process. So we need everything not only in the design requirements, but also in the process controls and how the processes are going to assure that those physical requirements are delivered. When I say physical requirements, I mean critical to quality characteristics that are necessary and related to user safety. And then finally, information for safety. Well, those are just design requirements related to the labeling and or to the training. So if we have all these requirements in place and we show the traceability and their relationship to the hazard situation, what happens is we have a complete total mitigation strategy that's built into the traceability of the design. So therefore, when we finish our V&V testing, we're going to have the evidence that shows we're compliant with all of these, and we'll be done showing that we've implemented and that our mitigations are effective in controlling what it is that we're concerned about. So this is really the head of all this. Now, one of the really great things about this is once I've paired a harm with a hazardous situation, and then I've stamped it as something that's important. So we have a risk priority level that's important when we cross the P with the severity of the harm. That gives us the risk index or the risk priority level. What that does is it helps us to understand systematically what's important in the design. And that's really what we want to do. How do we assure the users are safe systematically across the entire design? And you can imagine that once that risk record is identified as high risk, that traceability to the hazardous situation, user needs, system requirements, design requirements, all becomes automatic. If it leads to the risk record that's a high risk, then we stamp each one of those levels with high risk. And it changes the way we think about the testing now, because we've essentially said that the requirement is of high importance because it could lead to a problem with user risk. Now we need to have a little bit more rigor maybe in the testing of the requirements, either at the design level or at the process level. So that's really the purpose of this, is to get us to a place where we have a systematic way to evaluate each one of these requirements risk and put it into the traceability so we understand very clearly how we're going to progress and assure that we have a safe device. So the head of that trace is the user needs. And what we want to do then is we already have the harm and the hazardous situation connected to the risk record. Now what we want to do is go through the progression, the hierarchy of the design, and decide which one of these requirements and user needs are used as mitigations to the risk record. Again, it's the head of the trace, and now we have this opportunity to carry it on down the line. Now, when we do this traceability, as I described before, the reporting structure looks like this. And so essentially we have the risk record, the harm, and the hazardous situation. We've defined the hazard as an attribute of the hazardous situation. We have the severity that comes from the harm, pre-mitigation P1 and the post-mitigation P1. So we cross P1 to P2, we get P, and then we cross P with the severity of the harm to get this risk index. And that's what the yellow and red boxes. They're saying we have a medium level risk, we have a high level risk that's associated with this line. Now, when we do our mitigation strategy, and when I say do our mitigation strategy, when we have all the user needs, all the system requirements, all the design, all the, the whole progression, when we have all those well understood, what would we expect the occurrence of the hazardous situation to be? That's what this P1 value is, the post mitigation P1 value. And once we put that in, we recalculate the RPL and get a lower result because we've reduced the occurrence of the hazardous situation to the point where we have an acceptable risk. On the very right here is that work item that is the user need. That's just the head of the trace. It's just to show where the head of that mitigation strategy starts. That's really what we're looking at there, okay? So that's really how this type of reporting ends up looking, is tabular, kind of an Excel spreadsheet, but it's all driven from the requirements data. So now we're going to go back to our decomposition of the requirements, and we want to understand now how we systematically evaluate this. We want to talk about really FMEA structures. How is it we're going to inform each level of this design requirement progression in order to evaluate each line item for risk? So we're going to take those system requirements and design requirements. The input to the system failure mode analysis is going to be the design requirements and the functional chains to describe functionally what we want the device to do, and from a system requirement standpoint, what we expect the outflow of that functional chain to be. Then we're going to identify failure modes and root causes, which are largely going to be systems that are missing components. If we're missing a safety system or we're missing some function, that is going to have to be mitigated with design requirements, which are outflows from individual functions that are deployed in single components of the system. So at the system level, what we're really saying is the risk is that the system is incomplete. And so we want to go through and analyze it to make sure that we have all the components of the system that are necessary to make sure that the functional chain is delivered and we get the capability that we want. Okay, so again, we have at systems FMEA, the input to the systems FMEA is the functional chain and the system requirements. Then we go through failure mode effect analysis where we have pre and post occurrence levels, and we have root causes, and now we end up with the design requirements that are necessary to assure that that system requirement is met. So we're just processing through the system's FMEA to say, are these functional chains complete? And you might imagine also that it's really important when we get to the design requirement level, how do we know that a design requirement mitigation strategy is effective? And the answer is really that the system requirement performs as expected. Do I have all the design requirements in place? How do I know that just because I have a design requirement, I know it's implemented, but do I know the requirement is effective? The only way I know it's effective is if it delivers the system requirement. So when we start talking about what do we mean by effectivity of a design requirement, really the design requirement delivers the system requirement. And that is the relationship we need to check to be sure that not only is the requirement implemented. And when I say requirement, what I mean is this mitigation strategy, this user-based harms mitigation strategy. How do I know it's effective? It delivers the system requirement. You have to check the next level up. Okay, so now we're going to talk about the design failure mode analysis. And in this case, now we're analyzing the relationship between the design requirement and the physical requirements. Okay, so now when we get down to the design failure mode analysis, we're going to be analyzing the relationship between the design requirements and the physical requirements this time. That's the difference really between a design failure mode analysis and a systems failure mode analysis is what we're analyzing. What result do we want to get out of this? So in this case, now we have a design requirement that we're going to analyze for failure modes and root causes driven from design functions that are delivered in one component of the system. Now, this is really necessary because those design requirements are related to different disciplines. Might be software, might be hardware, might be usability. This is where we've assigned it to a particular discipline, so we know which format of design failure mode analysis to put it through. And the reason I say that is when you do a software failure mode analysis, we don't have 20% failure. It either fails or it passes. There's not this statistical sort of analysis going on. It's 100% or it's 0%. Another example is usability. In usability, we have a construction that is cognition and perception errors. So we perceive something, which causes us to believe something, which leads to actions and use errors. So the format of the FMEAs is different based on the different disciplines. So it's at this level that we start splitting them up into different FMEA formats. So the design requirement is delivered by the function, and we know what discipline it is because the function's delivered in a particular component of the system that's assigned to a discipline manager. So a mechanical engineer, an electrical engineer, a usability engineer, whatever. So out of that root cause comes physical requirements. And those physical requirements are often going to be dimensions. They're going to be material callouts. They might be even manufacturing processes. But what we're trying to do here is identify what is necessary to be in place to check to be sure that that design requirement is always met. So let me give you an example. I have a sterile barrier bag, and the sterile barrier bag's function, the function of the bag is to prevent harmful bacteria migrating to the device, just as an example. Well, there's a lot of reasons that could fail. I might get a hair in the seal and that seal would leak, right? Or might get delamination in the seal. So I have physical requirements in the design, and those physical requirements might be a 3/8 inch bag seal, might be using Tyvek. What we need to do is assure that whatever is necessary to make sure that we have integrity in the sterile barrier bag is delineated and noted as a physical requirement in the design. That way, when we go to manufacture, we know what's critical to quality. And in what context does it need to be critical to quality? It needs to be sure that whatever the function is that's delivered by that design requirement, that function is met as a result of the work that's being done in the physical requirement. So really need to understand that relationship so that when we create one of these physical requirements, it's going to end up being the critical to quality characteristic that is run through the manufacturing process and the PFMEA. So this is both ends of the analysis. What are we analyzing? What are the failure modes and root causes? Okay, what do we need to have in place to assure that design requirement is met? All right, and so in the report, it looks just like the systems failure mode analysis, except on the left side, we're at the top of the design progression where we have the design requirement. We do our analysis with the occurrences, and then the output of this is the critical to quality characteristics that are going to be tracked through the manufacturing process and denoted in our outputs. So finally is risk management for the process failure mode analysis. So now we're going to analyze the relationship between physical requirements or our critical to quality characteristics. And remember, those critical to quality characteristics carry with it a risk that's been assigned that for the traceability up to the hazardous situation harm combination. So we know, is this an A risk? Is it a B risk? So now what we want to do is analyze that for the manufacturing process to assure we have process controls in place to give us that critical to quality characteristic. So now the traceability is very different. We have a physical requirement that needs to be realized in a part. Part has a characteristic. The part is realized in a process. The process is built from process steps. We're going to analyze the process steps and the characteristics for failure modes. We're going to identify the root causes, and we're going to end up with our process controls. So this is really the process failure mode analysis. And some of those process controls, there's process controls and there's detection controls. I kind of like to call detection controls scrap controls, because that's really what they are. If you're saying, I'm going to detect a problem, what you're really saying is, I'm going to control that problem by sorting the end product with a measurement. And so what you're really doing is, when you have those detection controls, is you're building into the process a mechanism for scrapping product, right? So process controls are obviously the preferable route. But in any case, you end up with this process failure mode analysis that bakes into the data model the justification for the process controls as a result of trying to deliver those physical requirements. So once again, we have this risk record. The risk record now traces to the harm, the hazardous situation, and then the head of the trace, which is the user need, but all of the requirement levels that are necessary to assure that we have this systematic view of how to mitigate the problem. And then in the traceability, in a second path, we have the systems failure mode analysis, the variety of different design failure mode analysis, and the process failure mode analysis. And in this, then we have a complete understanding from a risk management report standpoint of the entire traceability of what we're doing to mitigate that particular problem. This is the report that we want to be able to show to the agency that says we have our processes under control. Now, one of the really cool things about this too is the FMEAs are going to characterize every potential error and the occurrence, our perspective view of what we believe the occurrence of that error is going to be. So what we can also do then is bring in post-market data of any kind related to the harm of users, related to the failure of the system, failure of the design, failure of the process, and we can bring that data back into the system and compare it with what we believe the failure occurrence was prospectively going to be. And that gives us a real nice context to make decisions about how important this problem is. Is it within the bounds of what we expected? Or did we state that we thought it was going to be a 1 in 1,000 and it's a 1 in 10 error? And now we really need to take a look at the mitigation strategies and evaluate why they're not working. Maybe put new mitigations in place, maybe better understand how we did this deployment to change the design requirements or whatever's necessary to get the problem under control. So in this way, the risk management system becomes a live document. It's not a spreadsheet that sits in a file drawer someplace. We're analyzing it and saying, what is all the data that we have? How does it compare to what we did in the past, and making adjustments as we go? Much faster process for understanding and dealing with problems as they come up. Okay, so what's the complete picture? We have the user needs to requirements progression. Now we have, in the context of the relationship between the levels, we've identified the risks that can occur to cause a breakdown in the overall system. We have the capabilities, functional chains, and functions, our traceability to the systems modeling, and a functional understanding of how the thing is delivered. We also have the traceability to the test cases. So how are we going to assure that these are met? What test are we going to run? What's the procedure for the test? We have traceability to those external standard clauses. So we have an industry view of everything that's needed for the different scope issues inside of development of the project, whether it's 60601 or sterilization procedures or device specific stuff, testing procedures. All of the industry understanding has been baked into the requirements model. And then finally, we have this traceability to outputs. And when we do it this way, what we end up with is a set of requirements that has all these perspectives baked into it, so that we have a really clear and the best pass, I think, the best chance of getting our design requirements complete and also getting them as correct as we possibly can based on all of these different perspectives: systems modeling, risk management, external standards, the testing evidence, the whole picture. So that's really where we end up with, I think, a design control system that's really effective. And not only that, but fast. We have a methodology that we can walk through to get the design built out in such a way that we considered everything we possibly could in the design. Okay, so that's risk management in short. Again, my contact information is attached. Please feel free to link it in or subscribe to my YouTube channel or give me a call, send me an email. I'd be happy to talk about any of these issues. As I've always said, risk management I've never seen it deployed the same way in two divisions, let alone two companies. So I expect that you're going to have some things to talk about. Tell me I'm crazy and we'll see what we can do to get you squared away if there's anything that I can do to help. So really appreciate your time today and look forward to the next session.